If you're watching this, you've gone ahead and clicked the link to the video for the ionic bond dice activity. So I'm going to go ahead and complete roll one for you guys, and I'm going to go ahead and go over how to do this. And so what I've done is I have multiple tabs open, and so I have the dice activity open. I have the random dice roller, and how we get that is through the link that is attached to your ionic bond dice activity. I also have the dice roll sheet. Okay, and so I'm going to do roll one with you guys, but you're also going to be using this, okay, for each roll that you guys do. And so if you guys notice, I'm going to be doing roll one, okay, so it's already going to be completed by the time you watch this video. Okay, you're going to be completing roll 2, 3, 4, 5, and 6. Okay, and so I have a couple other things up that I'm going to use to help me. And so in your notes, you guys have used your charge. And so we have each group. Group 1 has a positive 1 charge, Group 2 has a positive 2 charge, positive 3, positive or minus 4, negative 3, negative 2, negative 1, and we're just going to ignore Group 8. Okay, and so you guys should be having this periodic table out because you're going to want to use it. Now, I've gone ahead and made a blank sheet of paper. Okay, and so I'm going to show you on this. You can have an extra sheet of paper out. It doesn't matter to me. Just make sure you're showing your work. Okay, and so if you need to take a picture of your work and upload it with your activity, that's fine. And so there's multiple ways you can do that. And so if you've noticed, there's going to be two ways that you can actually do ionic bonding. And so we can use the Lewis dot that you guys learned in the notes, or we can use the oxidation numbers. Okay, and so I'm going to go ahead and go over the activity with you. So going over the pre-lab. In order to be classified as an ionic bond, what two types of elements must be present? Well, what is an ionic bond? What two things do we need? Well, your answer should be it's a metal and a non-metal. Okay? And so that's what tells you it's ionic. So when we look at our periodic table, it's going to be an element in yellow and it's going to be an element in purple. Okay? And so that is what's telling you it's ionic. Now, this is a little bit of review. Positively charged ions are called what? And negatively charged ions are called what? And so what I want you to do is go ahead and pause this video and try to look back at your notes of parts in an atom in the ion part and see what you can find. So if you've gone ahead and unpause the video, a positively charged ion is called a cation, and a negatively charged ion is called an anion. Okay? And so what determines the charge of an ion? Well, think about it. What subatomic particles have charges? And so the way we find the charge of an ion is protons minus electrons. Okay, and so if an atom's neutral, okay, and they have equal protons and electrons, well, any number minus itself is going to be 0. Okay, so if I have more electrons, it's going to be more negative. Protons, it's going to be positive. Okay, so let's go ahead and follow the directions. So using the attached sheet for each roll to know which is your cation and anion. Okay, and so the attached sheet is going to be this dice roll sheet. And so you'll find it also attached in Google Classroom with the ionic bond dice activity. And so I'm going to be using dice 1. So your metals will be cations, your non-metals will be anions. Okay, and so you need to use the website for the dice if you don't have any. Okay, so if you have dice, you can just use it. But I've gone ahead and posted a website for you guys that will do a dice roll. And so here's the dice roller. And so I'm going to show you how to use this. So I have this up on a different screen. And so you're going to roll 4 dice at a time. 2 dice are to be metals and 2 dice are to be non-metals. And write down the metals and non-metals you have for a table under roll 1. So what I would do is I'm going to go ahead and randomize and roll again. Okay, so my dice are 3, 5, 5, and 6. So for these two first dice, I'm going to mark down my metal. So 3 is first, 5 is second. So I'm going to go to my dice roll and look at 3 and 5. Okay, and so I'm going to do metals first. So 3 is going to be my first element, potassium, and my second element is going to be magnesium. Okay, so down here, I'm going to go ahead and type in potassium because that was element 3, and I rolled 3. And then I'm going to go ahead and put magnesium. That is my second element. Now, I'm going to go back to my random organizer or my random dice roller. My last two dice will be my nonmetals. So I have a 5 and a 6. So I go back to my dice sheet. I look at 5 and I look at 6. So it's going to be oxygen and it's going to be sulfur. So I'm going to go ahead and mark down my nonmetals. So I'm going to use oxygen and I'm going to use sulfur. And so I want you guys to go ahead and fill these in as I'm filling them in so you can kind of see what I'm doing. So now I'm asking, what is my oxidation number? Okay, what is my charge is what I'm asking. And so you have to look at what group each of these elements are in. Okay, and so if I look at potassium, well, potassium is in group 1, so its charge is a positive and 1. And realize positive is a cation. So my metals will always be positive, and so they're always cations. So potassium, I'm going to go ahead and put it is a cation, and it's positive 1 charge. And so we're going to be using these charges today. Okay, and so for my second element, magnesium, I also go to look. Magnesium's in group 2, so it has a positive 2 charge. So it is also a cation because it's positive. So it's a cation, and it's a positive 2 charge. Okay, and so remember, cations are just positively charged atoms. Okay, and so I'm going to go ahead and do my nonmetals now. I'm looking for oxygen. So oxygen is in group 6, and it has a negative 2 charge. Okay, so I'm going to go down here. It's an anion, and it has a negative 2 charge. So looking at sulfur, it is also in group 6, so it also has a negative 2 charge. Okay, and so I'm going to go down to my worksheet again. It is also an anion, and it's a negative 2 charge. Okay, and so we're going to be using these charges potentially. Okay, and so now I have to figure out the chemical formulas. Okay, and there's two ways to do the chemical formulas. Okay, so the first one I'm going to do is potassium and oxygen. Okay, so I'm going to compare my 1 to 1. Okay, so potassium and oxygen. Okay, and so we're going to use this blank. And so I'm going to use my Lewis dot first. And so if I go ahead, I'm going to put potassium and I'm going to put oxygen. Okay, and so I'm going to be using Lewis dots. And so when I go to my Lewis dot, well, potassium's in group 1, therefore it has 1 valence electron. Oxygen's in group 6, therefore it has 6 valence electrons. So I'm going to go ahead and draw my Lewis dots. I have potassium and oxygen with their Lewis dots based on their valence electrons. Okay, and so just like we did in the Lewis dots, because this is ionic, we show the transfer of electrons. And to satisfy them, I'm going to have to add elements. And so I'm going to go ahead and draw another potassium because oxygen needs another electron. And so my ratio right now would be K 2 O, because I have 2 potassiums for every oxygen. And notice I've lost all my electrons and I've gained all the electrons that it needs to gain. Now, watch this. Okay, I'm also going to show you how to use your oxidation numbers because you don't always have to draw this out if you don't want to. Now, if this Lewis dot is what you like to do, by all means, do your Lewis dots if that's easy. Okay, but what I'm going to do is I'm going to go ahead. Let me make this box shorter. Okay, I'm going to go ahead and show their oxidation numbers. Now, let's look. Potassium, its oxidation number is +1, okay? And so if I look, potassium is +1, okay? And if I look at oxygen, it's -2, all right? And so I've wrote -2 for oxygen. So what you also can do is write your oxidation number. So it's going to be +1. And then what I'm going to compare it to is my oxygen, which is a -2 charge. And so I write it in a ion form. Okay, and so the charge always goes in the top right. Now, all I have to do is cross my charges. All right, and so if you look, I'm going to take this charge and I'm going to put it here. And I'm going to take this charge and I'm going to put it here. I just cross them and I put them in the bottom. Okay. Now I do not bring the charge with it. I only bring the number of the charge. Okay. So this 1's going to be here. So it's going to be K2 because that 2 gets dropped. So it's K, the 2 gets dropped here. Notice how I did not bring the charge. And then the oxygen, I bring the 1 down. Now, we don't have to draw the 1, but it'd be K2O1. Okay, but we know we don't have to draw that 1. So I want you guys to notice my formula is the same thing. So there's always 2 ways to do these problems. You can use the Lewis dot, or you can just cross your oxidation numbers. Okay, and they come out to give you the same formula. All right, and so when I go ahead and write this, my formula for potassium and oxygen is going to be K2O. Okay. And so the chemical name, remember, is going to name the first metal. So potassium is the metal. So I'm going to go ahead and name potassium, and then I go ahead and change the ending to oxygen. So it would be oxygen, so potassium oxygen. Well, remember, I changed the ending to "ide," so it's potassium oxide. All right. So let's go ahead and do magnesium and sulfur. I want you guys to try this one without me doing it. Okay. So pause this video, try magnesium and sulfur. Now I'm comparing the 2's. Okay, so I want you to try to do the Lewis dot and also try the oxidation number. Okay. Now, I'm going to go ahead and do this now. So if you've gone ahead and pause the video because you've attempted this on your own, well, let's see if you've done it correct. Okay, and so I'm going to do the oxidation number, or I'm going to do the Lewis dots first. So I'm going to go magnesium and sulfur. So I'm going to go ahead and add magnesium. I'm going to go ahead and add sulfur. Now, you should have seen magnesium's in group 2, therefore it has 2 valence electrons, and sulfur is in group 6, so it has 6 valence electrons. Okay, in doing so, okay, magnesium is going to give 2 electrons, and sulfur wants 2 electrons. It fits perfect. So this one's a relatively easy one. Okay, so it becomes MgS. Okay, so that is my formula because magnesium's given 2, sulfur has taken 2. It's worked out perfect. So I only have 1 magnesium per 1 sulfur. Well, let's go ahead and use the charges. Okay, so magnesium, well, if we look, magnesium's in group 2, so its charge is +2. Okay, and if we compare it to sulfur, sulfur is in group 6, so it's -2. Okay, now what you guys will do is you'll cross the charges. And so this 2 is going to come down to the bottom of S, and this 2 is going to come down to the bottom of Mg. So what you're going to get is Mg2 S2. Okay, and so what you guys are noticing is you're going to say, well, Mr. Safi, that's not the same formula. But wait a minute. Okay, is there a number that each one of these two, can it be reduced? Is there a number that can go into both of these numbers that can reduce those numbers? Well, if you think about it, okay, magnesium's got to be reduced to its simplest whole form. And so if you think about it, I can divide each one of these numbers by 2. So 2 divided by 2 is 1, and 2 divided by 2 is 1. And so what they do is each one of these can be reduced by 2. So what this happens to be is MGS. Okay? And so you can always use each one. Just know when you have subscripts that can be reduced, reduce them. Okay? And so I've reduced it into its simplest whole form, 1 magnesium to 1 sulfur. Okay, and so whichever one you like to use it. If you like Lewis dot, awesome. If you want to use and try the oxidation numbers, do it. Okay, and so if I go back, okay, my formula for magnesium and sulfur is MgS. And once again, if I were to name it, it would be magnesium sulfur. But remember, we always change the ending of that nonmetal. So it's magnesium sulfide. Okay, and so this is what you're going to be doing for each roll. Okay, so for roll 2, I'm going to go back up here. I'm going to randomize it again. And then remember, the first 2 dice go to your nonmetal, or your metals. So it's metal 1, metal 2. Your second 2 go to your nonmetal. So your nonmetal 1, your nonmetal 2. And so you would go ahead and look at your dice sheet for roll 2, okay, and pick your metals and nonmetals. And then you would go ahead and start roll 2. All right. So you would find your oxidation numbers using your periodic table based on the group. And then you're always going to use either your Lewis dot or your oxidation numbers to find your chemical formulas. And that's what we did on this sheet. All right. So go ahead and try the next 5 rolls. Okay, roll 2, 3, 4, 5, and 6. Okay, and when you finish, go ahead and submit this.